Hello everyone, this is dear Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. Problem. Form the partial differential equation by eliminating the arbitrary constants a and b from z equal to xy plus y into square root of x square plus a square plus b square. So we need to form a partial differential equation by eliminating the arbitrary constants a and b. I mean a square from, a and b simply. So let's see the problem. Consider as equation 1. Now partially differentiate 1 with respect to x. Well, partially differentiating with respect to x, we'll treat y as constant, right? Partially differentiating one with respect to x. So here I'll show you the detailed process of by increasing the number of steps, okay, and again we'll solve the same problem by reducing the number of steps. So just apply dou by dou x on both sides of 1. Partial derivative of z with respect to x is dou z by dou x. Since z is a function of x and y, where x and y are independent variables, equal to partial derivative of first term of RHS with respect to x plus partial derivative of second term with respect to x plus partial derivative of last term with respect to x. We have a notation since dou z by dou x equal to p. Since dou z by dou x equal to p, so let's replace it by p. You'll get p equal to, here y is constant, so you can write it as y into dou by dou x of x plus, here y is constant, so we'll write it as y into dou by dou x of square root of x square plus a square plus partial derivative of a constant with respect to x is 0. Since we know that derivative of square root of x is 1 by 2 root x, okay, but here we are having square root of x square plus a square, so we need to find inner derivative also. This gives us y into partial derivative of x with respect to x is 1 plus y into derivative of square root of x square plus a square, that is partial derivative of square root of x square plus a square with respect to x is 1 by 2 root square root of x square plus a square into inner derivative, that is partial derivative of x square plus a square. This gives us y plus y into 1 by 2 into square root of x square plus a square into partial derivative of x square with respect to x plus partial derivative of a square with respect to x. This gives us y plus y into 1 by square root of 1 by 2 root x square plus a square into partial derivative of x square with respect to x is 2x plus partial derivative of a constant with respect to x is 0, which gives us y plus y into 1 by 2 into square root of x square plus a square into 2x, right? This gives us p equal to y plus y into 1 by 2 root x square plus a square into 2x gives, let me write one more step here, okay, these two. From these two you will get 2x by 2 into square root of x square plus a square, right, where 2 gets cancelled, which gives us y plus xy by square root of x square plus a square. Now take this or bring this y to LHS, you will get p minus y equal to xy by square root of x square plus a square. Now take this to LHS, you will get p minus y into square root of x square plus a square equal to xy. See, you can just stop it here, but by observing 1, you can just think of replacing square root of x square plus a square. Okay. Now we can take this to RHS, you will get square root of x square plus a square equal to xy by p minus y. Consider as equation 2. So we got equation 2, square root of x square plus a square equal to xy by p minus y. Now partially differentiating 1 with respect to y. Partially differentiating 1 with respect to y. Okay. Apply dou by dou y on both sides of 1. Since z is a function of x and y, you'll get dou z by dou y equal to partial derivative of first term with respect to y, the second term plus last term. Since we have a notation dou z by dou y equal to q, so let's replace it by q. We'll get q equal to, we can write this as constant into partial derivative of y with respect to y. Since we are partially differentiating 1 with respect to y, so we'll treat x as constant. Okay, plus constant square root of x square plus a square into partial derivative of y with respect to y plus partial derivative of constant with respect to y is 0, which gives us q equal to x into partial derivative of y with respect to y is 1 plus constant into partial derivative of y with respect to y is 1, right, which gives us q equal to x plus square root of x square plus a square. Now bring this x to LHS, you'll get q minus x equal to square root of x square plus a square, right, or you can just write this as square root of x square plus a square equal to q minus a. Consider it as equation number 3. Now observe 1, 2 and 3. By substituting 2 and 3 in 1, it's not possible to eliminate a and b, that is arbitrary constants. So observe 2 and 3. From this we can say that xy by p minus y equal to q minus x, since square root of x square plus a square equal to xy by p minus y and q minus x. So let's equate this. From 2 and 3 we get xy by p minus y equal to q minus x, right? Now take this p minus y to RHS, you'll get xy equal to q minus x into p minus y. Simplify this, you'll get pq minus qy minus px minus into minus plus xy. See, in LHS also you are having xy, so you can cancel xy directly from LHS and RHS, or just bring all these three terms to LHS. You'll get xy plus qy plus px minus xy equal to pq, where xy minus xy gets cancelled and you'll get qy plus px equal to pq, or we can write this as px plus qy equal to pq, which does not involve any arbitrary constants, and also it is of the form of equation f of x, y, z, p, q equal to 0. So we can say that from this we can say that this is the required partial differential equation. Therefore, px plus qy equal to pq is the required partial differential equation. This completes the problem. Okay, now let's see the same problem by reducing number of steps while finding partial differential equation. Partially differentiating 1 with respect to x. Dou z by dou x equal to partial derivative. Since we are partially differentiating with respect to x, so y will be treated as constant. So we can write this as y into partial derivative of x with respect to x is 1 plus y into partial derivative of square root of x square plus a square is 1 by 2 root x square plus a square into inner derivative, that is partial derivative of x square plus a square. Partial derivative of x square with respect to x is 2x plus partial derivative of a square with respect to x is 0 plus partial derivative of constant with respect to x is 0. Since we have a notation dou z by dou x equal to p, so we'll replace it by p. You'll get p equal to y plus 2xy by 2 times square root of x square plus a square, where 2 gets cancelled. Now bring this y to LHS, you'll get p minus y equal to xy by square root of x square plus a square. From this we'll get square root of x square plus a square equal to xy by p minus y. We'll simply take this square root of x square plus x square plus a square to LHS and bring this p minus y to RHS. From this we'll get square root of x square plus a square equal to xy by p minus y, which is our equation 2. We have considered as equation 2. Okay, now partially differentiating 1 with respect to y. Since we are differentiating with respect to y, so x will be treated as constant here. We'll get dou z by dou y equal to, here y with respect to y we are finding partial derivative with respect to y, so x is treated as constant, so we'll get x into, which is a constant, into partial derivative of y with respect to y is 1 plus x square plus square root of x square plus a square is treated as constant. You'll get square root of x square plus a square into partial derivative of y with respect to y is 1 plus partial derivative of constant with respect to y is 0. Since we have a notation dou z by dou y equal to q, so let's apply it. We'll get q equal to x plus square root of x square plus a square. Now bring this x to LHS, we'll get q minus x equal to square root of x square plus a square, or we can write this as square root of x square plus a square equal to q minus x. Consider as equation 3. See, we got the same thing, right? Now observe 1, 2 and 3. It is clear that by substituting 2 or 3 in 1, the arbitrary constants a and b won't get eliminated. So what we'll do is, we'll just observe 2 and 3. From this we will come to know that we can equate xy by p minus y equal to q minus x, right? From 2 and 3 we get xy by p minus y equal to q minus x, which gives us, right? Now simplify this. pq minus qy minus px plus xy. Now bring these three terms to LHS. We'll get xy plus qy plus px minus xy equal to pq plus xy minus xy gets cancelled and we'll get, right? Or we can write this as px plus qy equal to pq, which is the required partial differential equation. Therefore px plus qy equal to pq is the required partial differential equation. Which completes the problem. Well, we have seen a problem from partial differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.